quantitative forecasting methods are based on the apparent causal relationship between two variables such that change in a measurable variable causes a predictable change in each other. The measurable variable affecting the change is called a leading indicator. Sufficient number of leading indicators enable excellent forecasting results. For some objects, market survey adds the forecasting. Quantitative forecasting methods based on causality are often time consuming and expensive, primarily because of developing the relationship and obtaining the causal data. The best example of a causal forecasting is the regression analysis. It is basically a statistical technique in which past demand data, that means the historical data of the demand of the product, is used to establish a functional relationship between two variables. One variable is known or assumed to be known and used to forecast the value of the other unknown variable, and trend line analysis is another statistical method of causal forecasting. In this analysis, the trend line, that is line of the best fit, is drawn on a scatter diagram which represents the trend in the data. The trend line tells whether a particular data set has increased or decreased over a period of time. The most common quantitative forecasting methods are based on the assumption that past demand follows some pattern. It makes some sense. The historical demand makes some sense. And it can be used in developing projection for future demand. The first step in making a forecast is gathering information from the past in the form of statistical data recorded at a successive interval of time. Such a data is usually referred to as a time series, and hence the name time series quantitative forecasting. The demand data is plotted on a time scale to study and look for consistent shapes and patterns. Such methods are commonly known as time series forecasting because time is the only real independent variable in statistical data. Since these methods are based on internal data, that means of sales basically, they are sometimes called as intrinsic forecast. We have studied about intrinsic forecast and extrinsic forecast in the last lecture itself. For understanding the reason behind the trend of demand in time series, forecasting helps. The pattern can be random, unpredictable. It can be trending or apparently definite, or it can be seasonal or periodic as well. Now, some of the common time series forecasting models are simple average method, simple moving average method, weighted moving average method, and exponential smoothing. These four methods often comes in form of numericals in many examinations. So let's understand them one by one. You need to have a brief description about them. You don't have to have a comprehensive one. See, simple average method forecasts the demand of the next period as the average of demand occurring in all previous time periods. Let's say the demand for one particular product for the next month will be calculated on the basis of occurring demand in the previous months. Let's say for January, February and March. In 3 months, the demand for a particular product was 2 unit, 2 unit and 2 unit. So for the very next month, that means for April month, the demand would be given by 2 plus 2 plus 2 by 3. That means 2 itself. Now we have simple moving average method. In simple moving average method, the average of the demands from several of the most recent period is taken as the demand forecast for the next time period. Here also, the number of past periods is used in calculation, which is selected in the beginning and is kept constant. Let's say, for example, let's take the same example, January, February, March. The demand of the product was 2 unit, 2 unit and 2 unit. if in the numericals given that moving average of 2 months is being taken, then 2 plus 2 divided by 2 is equal to 2. That would be your simple moving average method. But do not get confused with simple average method. Simple average method just takes the average of the previous demands. It can be 4 months, it can be 6 months, it can be 3 months, or it can be 1 month itself. But for simple moving average method, it gives you a time period. Previous 2 months, previous 1 month, previous 3 months. 3 month moving average, 2 month moving average, like that. And on the basis of the same, forecasting is done. Then we have weighted moving average method. In this average method, unequal weights are assigned to the past demand data while calculating simple moving average as the demand forecast for the next time period. Usually, the most recent data is assigned as the highest weight factor. And this kind of average you must have definitely have studied in quantitative aptitude. Then we have exponential smoothing. In exponential smoothing, weights are assigned in exponential order. Let's understand exponential smoothing with its formula itself. Let's say the forecast for time period small t is related to the demand for the previous period. Let's say the previous month as d suffix t minus 1, and forecast of previous period f suffix t minus 1, which is given as f suffix t is equal to f suffix t minus 1 plus mu, that is the smoothing constant here, in bracket d suffix t minus 1 minus f suffix t minus 1. Now what are these? F suffix t is the forecast of the time period under consideration, or the forecast that you require, the forecast that the forecasting team requires. And f suffix t minus 1 is the forecast of the immediate previous month or the previous time period. It can be month, it can be week, it can be day. Mu is what we call the smoothing constant, which takes care of the forecasting errors also of the old forecasting. And basically this mu is a constant value which you will always find in your numericals. And d suffix t minus 1 was the demand of the immediate previous month or the previous time period.